This is a short video to show AdaptEve in action. I'm not going to go into too much detail about the concepts behind it, as I'm more interested in just showing the program running, but if you'd like more detailed information you can find it on my website in the project section. The full project report for AdaptEve can be found there. To try to briefly explain what AdaptEve is, it's an artificial intelligence system which is driven by artificial life. And in this case, the artificial life is an L system, which is an algorithm that tries to simulate tree goat behavior. AdaptEve grows the L system and tries to use it like a network of neural pathways, and information is guided through the artificial intelligence system using that network. This window gives a general overview of the system. Along the bottom we have sensor inputs, along the left we have data processing nodes, along the top we have memory, and on the right we have outputs. So when the system was first made, it was connected to a Bobot, which is a small hobby robot with various sensors and motors. And each one of these ports would correspond to a different sensor like light, touch, and so on. And each of these output ports would correspond to a different motor or servo on the robot. The way that the system works is that data has a path along which it would ideally like to travel. Data originates in the sensor inputs, and ideally it would like to travel to a data processing node. From there, the data would ideally like to go to memory in case it needs to be referenced in future cycles. And from there, the data would ideally like to go to the correct output port. Due to the way that the L system works, it's not always possible to have a connection to the section that the data would like to go to. And in that case, the data will flow to the next ideal place that it wants to go to. This allows for interesting situations like sensor inputs being routed directly to motor outputs, and the idea behind it was to try to allow something like reflex actions where the robot would take action immediately in response to stimulus without bothering to process the data. So if we start the system, the L system starts with 5 branches initially, and each branch splits into 2 child branches at random intervals. The branches are in a constant state of withering or dying off, and branches are given a temporary state of reprieve every time they sprout child branches. They're given the equivalent of virtual food. So as we can see, this branch has made a connection with one of the sensor ports, and data is starting to flow along through it. Data has to flow back to the center of the L system, and from the center then it will go to its next destination. Yellow corresponds to sensor inputs. Green corresponds to processed data, red corresponds to data which has been stored in memory, and then data which is black means that it's gone to an output. So as we can see, data travels through the system. Once it reaches the data processing node, it turns green, then it heads to memory, and going back to the center again, goes out to an output. The system will continually grow and change and adapt. It's similar to exploring its environment. Occasionally the established branch connections are allowed to be usurped by newer child branches, and it just keeps the system fresh and dynamic and changing. So I'll set it to quick speed and leave it at that.